Awesome. Thanks. Well, good morning, DerbyCon. How was last night?
Great.
Yeah? Awesome. Well, I'm Josh. This is Matt. We're co-presenters for today. We'll do a little introduction, but first a couple of disclaimers. We do work for a Big Four accounting firm, Ernst & Young, so we do have a couple of those to go through. First thing we want to say is what this is and what this is not. The purpose of this presentation is to not go through the technical details of exploiting vulnerabilities on an industrial control system. I think if you've gone to any of the other presentations, they've talked about, hey, we all know that you can exploit a SCADA system. We know you can get into a Siemens S7 controller. We know that you can get into an ABB relay. We know that that can occur. And we take that as a fundamental assumption coming into this. What it is meant to be is a discussion on once you own that box, once you have control of that relay, what do you do and why would you do anything at all? What's the purpose of it? It's one thing to get there, but you need to know what you do with it after. And we want to talk a little bit about that. So what are some attack vectors, which gets a little bit into technical details, but not too much. And then go through what would be the motivation, who would be the threat actors, what would you want to try and do with that control. Also, what it isn't, since we're with an accounting firm, we are not here to help you with your taxes. So please no 1040 questions. We also don't do 401k planning with you in this session. So please seek Fidelity out in that green line to start with that. And we're not doing any other type of financial auditing. Also, we really enjoy our jobs. I think a lot of speakers have said that. We like what we do. We like the company that we work for. And because of that, we have a lot of client privacy to think about. That said, if any of you attended like Chris Nickerson's presentation, which was phenomenal, awesome, lots of great detail, we won't cite any of our client names, but we will definitely cite client experiences and things that we've seen, and we've seen quite a bit. So we'll talk through that. It is meant to be disclosure. That's the purpose. When we talk about what you should do, who would be the threat actors, why you'd want to do anything with the control that you can gain over an ICS system, it is meant to be that disclosure format. So ask us questions. We'll tell you what we've seen. We'll tell you what we've seen other people do. If you went to Josh Corman's presentation, that was another great one. One thing he said at the end is that his 3 words that he once said at his eulogy was that he was honest, courageous, and of consequence. And we hope that this presentation is that.
Couple other notes before we get started. First and foremost, we would like to thank the Crystal Method for opening up for us last night. We appreciate it getting up here on stage. There will be no angle grinders up here today, though, so I think you guys might be a little disappointed. And again, due to our employer, I can neither confirm nor deny that there's some liquid courage up here. If anyone's having trouble waking up this morning, you're more than welcome to enjoy.
Yep, so thanks a lot. Appreciate you guys being here this early morning. We know the party last night was raging pretty good. We were there. So a little bit about us. So I'm Josh Axelrod. I lead the information security practice at Ernst & Young for the power and utility sector. I focus mainly in the electric sector, although we do oil, gas, water, chemical as well. I was a former NERC SIP auditor, and usually that doesn't go over too well with audiences. So if you have any familiarity with regulations in the electric sector, NERC SIP is a cybersecurity regulation that is present there. And I used to audit that for about 18 months and led the team out in the West. So I covered all of the Western United States and did cybersecurity audits there. I am also a retired naval submarine officer, so nuclear engineer by education and practice for my first 12 years, and then switched over to information security in some of my last few years in the Navy, and then once I went into the private sector. I am Matt's boss after he got done auditing, but only because I had the foresight to pull him out of our financial services organization where he was residing when I came to Ernst & Young. I do have some certs. I have some certs pending. Can't really talk about those. I don't know that they really matter. It's more about experience and the certifications that you have, and we certainly have a lot of that.
As Josh said, I'm part of his practice. I joined it officially as of July. I also was a former NERC SIP auditor. If you want to beat us, wait till after the presentation. That was in the southeast area, so between the two of us, Josh and I have probably audited every major, about half of the major energy utilities across the U.S. So seen quite a lot, and that's a lot of why we're able to come up with some of these views here. Came from a variety of backgrounds. Yes, I was one of those PCI QSAs for 4 years too, another reason if you want to beat me up. But my biggest claim to fame here is that I was actually Dave Kennedy's first boss, hired him out of the Marines. So he owes everything to me. So in some way, you guys all owe me. Put that on record.
I think, we do want to take just a minute. We've had some other people do some shameless plugs for hiring. We certainly are. We're always looking for good people at the firm to bring them in, assist with attack and penetration, social engineering. Sometimes assisting in auditing. We try to stay away from security auditing and focus more on security program build-outs and things of that nature, and architecture design and things like that. So if you're interested, come see us after we get done here. Now moving on to the presentation. The mystery that we want to talk about today. We all know that organizations across all sectors, not just the electric sector, not oil, gas, everything, healthcare, banking, everyone's being attacked, right? There are perpetrators that are trying to go after personal private information, trying to go after financial data. There's numerous attacks going on out there. We're all well aware of that, right? We also know that specific for our industrial sectors, processing, manufacturing, electric sector, our industrial control systems are insecure. We started off with that. We know we're going in with a fundamental assumption that you understand that concept. You can go to sites like Digital Bond. You can see studies on where they've broken into relays and they're breaking some of the ICS that's specific to the electric sector. That's nothing new. We also know that regulation across the board is usually pretty poor as far as actually enacting good security principles. Setting a minimum baseline, trying to get everyone somewhere where you can get to audit them and verify that at least they're doing something. We know that that exists, and it's not really helping to pull us towards a strong security stance. So the question becomes, why hasn't the grid been hacked? If we know that the systems are insecure, right, we know that they don't have good regulation that's forcing them to do good security principles, why hasn't it been hacked? Sir? Great question, and we figured that'd be the first response we get. And we don't, right? We don't know that for sure someone hasn't done it and it's been kept from us. We don't know all the information. We don't know what we don't know. But from what's publicly available, not a lot of information on how the grid has been hacked. We have some examples that we think are relevant, but anybody else? That's an easy answer, right? How do we know that it hasn't?
And just a point, this whole slide, this whole concept came from, it's about 2 years ago, and I was at the meeting of all the different energy regulatory guys, and the auditors sitting around, and there's a guy up front, going, oh man, here's how easy hacking is, and he was done. And this was the question I asked him. I'm like, so why hasn't it been hacked? And he just was like, So it continued to just burn in my head. So, you guys are all really smart. You guys are all great hackers. Why hasn't it been hacked? That's a great one. We'll be covering that.
Perfect
You
answer.
can, actually. And we'll show you how.
But that's where we're at. We understand, we know that you can get to the point where you own a box, you can own the control system. We know that you can do that, but no one does anything after that. That's it. They just take the snapshot, we're good. Yes, sir. Are we talking about that? Is that in our scope? Yes, it is.
Yeah. Sure.
Right.
Yeah.
And we're trying to get to the point of why hasn't something actually been done that's caused harm other than proof of concept and showing that you can get the whole thing. That's where we're trying to go. And that's one of our key tenets, right, is people don't know how to make money from it. It doesn't seem valuable at this point. It's more of a curiosity. Can we do it? Yes, we can. We should be concerned. We should protect against it. But why? What's the motivation? Because that's always going to be the business case with executives, right? Why are they going to put any spend into security products? Why are they going to do that? They have to know that there's a risk, and they have to know what it is to their business line. Yes, sir.
And we'll
Agreed.
talk about terrorism as well.
See, now all the good
Thank
ideas
you,
are coming
guys.
out. Sir. Say it again. Agreed. Agreed. If you didn't hear that, just saying that the time isn't right to exploit what they found.
Yeah, and we'll talk a lot about the theys, who are the different threat actors, and why they may be delaying. So the way that this deck is organized is we're going to go a little bit over the past, talk about has it been hacked, and certainly in some respects we have a variety of cases where to show that it absolutely can be done, just not in a grid level concept. Then we'll also go a little bit into today's landscape and try and get a better sense of where we're at, And then we're going to kind of go into the future a little bit. This is probably the meat and potatoes, the big bang of our deck, really outlining what we feel are a lot of likely scenarios and exactly how someone would take out the grid or parts of the grid because they're the right threat actor, the right type of vulnerability, and a good likelihood for it.
So how it's been hacked, or has it?
So first one is someone that, unless you're in this industry, a lot of people have not heard of. This is Night Dragon. Who has actually heard of Night Dragon? Okay, so quite a few people. This is this was an APT before we were using the buzzword APT, but this was a systematic breach of oil and gas companies and some energy companies that were targeted. And the main thing that they were looking to do is go after the to go after the marketers, find the guys who are actually trading oil and gas futures and have the inside track. So that goes to one of the points of how do you make money? Well, they found how to make money in the oil and gas industry. It's much harder to do it in energy, but we'll still show you how you can do that. The next one, Shamoon. How many people are familiar with that? Probably a few more. This is something, this particular attack was one in which a virus was really introduced to Saudi Aramco, their big provider of gas, and took out 30 with the full intention of simply just, it's a denial of service attack basically. They took out 30,000 of their computers and they had to spend a pretty long time rebuilding it. And to me, it was one of the more interesting attacks because I don't know how many of us have ever really thought about that. I mean, if someone at your, if you're working for a pretty big company and they said, guess what, you've just lost every desktop in your environment, that's a pretty oh crap moment. But again, goes to show this was someone intentionally trying to sabotage someone in the power and utility industries.
And for Matt and I, that particular one was personal. We had a good friend who used to audit with us, took a job for Saudi Aramco, had worked there before, had come on as their director of IT architecture in Saudi, and he had been there about a month when this happened. So he just had like a total shitstorm to go through. It was ridiculous. We felt awful for him. He called us asking for advice, trying to get help. They just didn't know what to do. And we've seen this type of attack in the electric sector. I mean, not quite a DDoS, but very, very similar, right? When McAfee rolled out some signatures, it was probably, a year and a half ago?
Yeah, vendor DDoS.
Right? McAfee releases those those signatures. They roll them out to their corporate workstations. A utility that we all know and have worked with very, very often lost all of their enterprise workstations. Everything went down. And they were one step away from rolling it out to their control system. The first test was rolling out to enterprise. So, very real things that can happen in the electric sector, and we've seen it come very close. Who hasn't heard of Stuxnet? Right? Yeah. We won't be as rude as some of the other presenters that would kick you out if you hadn't heard of it. But Stuxnet was very targeted at control systems used in the industrial environment. A Siemens S7 controller. Stuxnet essentially manipulates the ladder logic based on a social engineering principle. Get someone to plug in a thumb drive, and it can alter that ladder logic within the control system. And in this case, it was specifically targeted at Iranian centrifuges, right? And it would cause them to spin out of control and break. Well, the same principle could be applied to turbine vibration monitors at generation plants or any type of rotational mechanical equipment. Right, that inertia can cause them to break, and these are big pieces of equipment. I mean, just at a hydroelectric dam, a small hydro dam, if you've ever seen those, the turbine shafts that are on those are about 4 to 5 feet in diameter. Those are huge pieces of equipment, and causing it to overspeed or overspin can increase torque and can cause it to break. And it's 2 to 3 years sometimes before you can replace a shaft like that. It can be enormous lead times due to testing, installation, and really can put a system like that, a generation plant, out of commission. And that's actually where Aurora came in. So Aurora is a vulnerability. It was tested by the national labs, widely publicized. Has anybody seen the Aurora video? Okay, cool. There's Operation Aurora, which is different than the Aurora
That's
vulnerability.
Google in China.
And the Aurora vulnerability was essentially an electrical engineering principle. The ability to circumvent relay protections and cause, very much like Stuxnet caused a centrifuge to spin out of control. Basically, use electromechanical principles to over torque a shaft and break a shaft on a generator by closing it out of synchronous phase. Now, I know some of the electrical engineering terms maybe you're not familiar with, maybe you are, but one of the ways to take advantage of the control that you can get over an industrial control system, the electric sector, or any other sector, is having that electromechanical knowledge and understanding the principles of operation and being able to circumvent relays or reset them such that you can destroy equipment. Lead times are enormous on these pieces of equipment.
And so a couple extra notes for the great interesting thing about Stuxnet. This goes back to one of Chris's points, if you saw. We're talking about a convergence type of attack. Yes, there was social engineering to get the thumb drive in there, but it's really ingenious because it was also designed, we know how industrial control protocols aren't that strong. They never knew that these things were spinning out of control. They essentially were muting a lot of that information. So I thought that was particularly interesting. And Aurora, for those who don't know, how do you break a shaft? Pretty simple. I had explained to me, if you've ever driven a stick shift car, you know what happens if you bring the clutch, dump the clutch, and you'll effectively stall the car because of the mass of the car versus the motor. It's just too much. Well, you got to imagine these generation plants are like the motor, but you got to imagine that the grid is its own motor that's that's hundreds of times more powerful than the motor. So now you're actually doing motor-to-motor synchronization, and that's how much torque and to Josh's point, could literally destroy a huge generator at that point.
Yeah, and I'll back up off, but you saw me pull JP Morgan away before we talk about that. Matt just reminded me, I'm a big fan of Schweitzer Electronic Laboratories. Anybody heard of SEL before? Okay, great company, right? They make tremendous products. They really work hard to try and build security in. Once the SIP standards came out, that was their biggest client. They've really gone to great lengths to hire in expertise and do architecture, and their new equipment is coming out with security architecture built in. Authentication, strong off on wireless capability. They're doing a great job, and the founder, Ed Schweitzer, is a big proponent of security. If you look up Aurora and SEL, you'll find a white paper that they wrote. Very good white paper. It was very sound from an engineering perspective. Gave a lot of good information, talked about what the real vulnerability was, that it was a very small time window. They cited the types of materials and knowledge that an individual would need and the type of access. What was really interesting in that white paper is if you look, they give you like an attack tree, all the things that had to be true in order for them to be able to execute the vulnerability. And if you look at the cybersecurity tree, they cite 5 things as there's no way this will ever happen and be true. One of them is that they'll never be able to break our authentication that's on our system. They'll never be able to crack passwords. They'll never be able to get physical access to the system. There's no way that they would ever have the tool they need to operate a breaker. Right? These are the things that they cite as being the impossibilities that make the Aurora vulnerability not a real option. And they're great guys, but it was just off base. We break authentication all the time. People use weak passwords and use default passwords, and we crack them. Chris Nickerson went over all the details of physical break-ins, physical breaches during his social engineering efforts. I mean, that stuff happens, and it was just funny that that whole cybersecurity attack tree was very common things that are compiled in penetration tests and social engineering.
So, J.P. Morgan Chase, did anyone read about this one where they're getting fined for $400 million? Okay, so what the takeaway from this is understand is that everything that's being done with energy is a real-time trading. There is no like, hey, I'm going to go, there's no futures market. There's no real, there's no real way for you and I to deal in energy to try and make money that we're aware of. And even so, you have a situation where J.P. Morgan Chase was allowed to participate in that, much like an Enron, and they were able to manipulate the market to enough to deserve a fine of $410 million, which I thought was like pretty awesome, huge, and well, now they're getting hit for $11 billion. Sorry if any of you are with JPMC.
So substation sabotage. Anybody hear about the Pacific Gas and Electric, San Francisco, California? What happened out there? Got one hand over here, another hand over here. You're watching all the news. I love it. So Pacific Gas and Electric had an incident where someone essentially went and used a high-powered rifle and shot their gear at one of their substations. It was going to take, once the damage was assessed, the transformer was going to have to be replaced. It had drained all the oil. It had overheated. Coils had been damaged within the transformer, and they needed to replace it. And it was fairly large. The idea is that it was probably an insider threat, someone that had knowledge of the system, knew that that was a very important substation, knew that it was a very important transformer, and that transformer was put out of commission for 18 months. These, like I said, I've said several times, lead times on equipment is enormous. We get everything from China. Very few things are actually manufactured in the U.S. on a large scale, just due to the environmental concern. So we have a nation state building our equipment, giving us long lead times to sending it to us to replace our gear. So we're very susceptible to some type of substation sabotage, and we'll talk a little bit more about that. They also cut fiber lines. That was more aimed at emergency services in that case, but you can easily get to the communications gear and disable that, whether it's hanging on a line or buried underground. Not a lot of security around that infrastructure. All right, so why hasn't it been hacked?
So our favorite friend, security through obscurity. I hope none of you are practicing this. For the longest time, and we've heard this story in other industries, no one's going to be able to hack this because they don't know, even if they could get in, they're not going to know what to do. Trying to get information on these kinds of systems and whatever is going to be incredibly difficult, but that's simply no longer the case. I mean, most of the equipment out there, the manuals are out there on the internet along with the default usernames and passwords. And so this particular premise, although you still hear people talk about it all the time, they're like, well, you're not an engineer, there's no way you'd know what to do, you're just some hacker guy. I'm like, no, hackers are pretty good at figuring out things they've never seen before. So we just kind of wanted to throw that one out to get started.
Another deterrent is the idea of the electromechanical system, and I use that term. People say, well, it doesn't really matter if you take our cyber stuff away. I can go out to a substation and run it, right? I can just go and do it. I can get on radios, and we can handle everything manually like we did before. We can do all the switching. We don't need this gear, so take it away. It's not important. The fact is, it is very important. Yesterday, Josh Corman, during his presentation, and Wynn later in the day during his presentation, we've become increasingly dependent upon technology, and that's become true in our educational system as well. In the Navy, when I was there training as a nuclear engineer, I was very fortunate. They trained us on gear that was 50, 60 years old. That was how we learned. So I know how to do it all manually. I can do it. The new gear just makes it easier, makes it faster, helps me react better. In the electric sector, though, people that are being trained are only being trained on this new gear. They don't know how to align parallel AC sources without a machine telling them how to do it. They don't know how to read indication and use voltage and frequency to get them to a point where they can parallel and bring a generator online and restore an electrical system. It's just not a skill that's being taught anymore. And much like the nuclear industry and other industries, we're seeing a phase out of our good engineers, our well-experienced people that have seen all that gear. They're going into retirement. And now you have a younger crew that only knows how to operate using an energy management system, SCADA-enabled equipment, and programmed logic controllers that they just have to hit a button and it does what they need. So we're going into a different type of environment, but that's been a deterrent. People have recognized, or people have been saying, we can just operate it manually. We don't need all of this gear.
And we've kind of been over this a little bit already, so I'll go through this fairly quickly. But again, what we recognize is that it's a semi-public market. There are some firms, so if you wanted to, maybe do some sort of attack where you wanted to go after a JPMC and try to get in and deal with it. But for the most part, again, that's a big deterrent. I think is the first answer. No one knows how to make money off the grid.
All right, so primary threat actors.
Okay, so what we wanted to do is break down who are the threat actors, at least 4 primary areas of threat actors, and kind of how are they involved today. We're going to take kind of the curious hacker, maybe that's most of you guys, You know, we've seen situations, you know, a sewage plant gets shut down because someone got on it and figured out, oh, hey, this looks like some fun game, and let me see what happens when I start operating these gates. And so maybe that's been the most number of incursions into the grid, but they're all at a very micro level, and really nothing that was done with harm, you know, with a lot of intent to harm. Activists. So we have seen situations where activists have gone out and disrupted energy companies that, you know, because they're not green and everything else. You know, they've done as much as scaling some of the cooling towers for some of the cooling towers for various power plants. So there definitely is that they are now activists themselves don't tend to get very motivated they're kind of soft, but there's certainly an opportunity for them to get involved. Hostile nation states, this is obviously a big concern. Have they already got in? I think this is probably one of the biggest deterrents we actually have, other than money, is, you know, let's say China already has hacked the entire grid like some people have alleged. The problem is, what are you going to do with it? If I'm China, first of all, taking out the grid is really not in my best financial interest. And the other thing is just, it absolutely would be an act of war. I mean, international humanitarian law, you know, all the war conventions state you just can't attack civilian critical infrastructure.
I think it goes to your point, though, that you made, right? I mean, the time hasn't been right. And for hostile nation states, it's waiting for the right opportunity. Maybe they already have all the right information. We've seen a lot about embedded devices. I mean, I mentioned that we get a lot of our gear from China. That's not, you know, that's not a falsehood. We really do. We ship everything in. Do we do factory acceptance testing? Yes. Do we go to the length of doing broad spectrum analysis once we install something and making sure that that's the right communication that we're getting out of it from a wireless standpoint? No, not always. So we may have things already embedded within our system, and there's been some evidence of that, some tampering found when there's been spot checks and inspections during factory acceptance testing from outside organizations from a utility. But waiting for that right time to be able to execute is very poignant.
Yeah. And to that last bullet there, I mean, we've seen recently where the threat was we are going to potentially launch a bunch of missiles into Syria. And the Syrian Electronic Army has already stated, yeah, go right ahead, and we'll be glad to, you know, return the favor. Yes, we don't have a bunch of big missiles, but we've got some guys that know what they're doing, and we'll see what kind of damage we could do. So that's where I start, you know, getting to be scary, where I think these smaller countries are more than willing to do something like that if they're very hostile. And then criminal organizations, again, right now, that drives probably the largest part of hacking, right? Everyone, you know, the bad guys are doing it to make money typically. It's a very good reason, I guess. And we still don't know how to do it yet.
So we actually, in the last 4 sets of slides, we do call out terrorism. And I guess, you know, with respect to that previous slide, and I'll pull it back up, we were kind of lumping them more into that criminal organization type of effort. They have some sort of purpose, right? They could be part of a nation state, and we don't know about it. Where do they fit in? I mean, I think what you said is absolutely right. They don't really have, you don't know what their motivation is. Sometimes it's just that they hate, and we don't know, so where do you lump them in? Well, yeah, I mean, they're kind of their own category. I think they fit across all of it, right? Yeah. They could be just curious, trying to figure out what they can do if they want to execute that hatred. They could be an activist trying to make some political statement, which often is true. They could be part of a nation state or sponsored by a nation state. That's very possible. And they could just be a criminal organization looking fun. I mean, it can vary. But we include them and use them in one of our scenarios in the last 4 slides. Yeah. Yep.
Yep.
Exactly. And
Yeah.
again, in the last four slides, we pull that up as one of the targets, and then that example of pulling JP Morgan Chase was exactly to do that, and the public trading aspect. So agree with you. Like, we think that they're now starting to figure it out. So now they become someone in the future that can be a primary threat.
But what we're seeing too is like JP Morgan Chase decided to exit the market after that. So that may be less of a possibility, but we'll show an easier way to make money. I mean, that's the whole point.
So attack vectors. Oh, go ahead. The internal threat?
Yeah. And we actually didn't go into the insider threat. I mean, we know it's a definite possibility, but we don't look at that as why someone's attacking the grid, right? You know, a lot of this presentation you'll see is at a macro level. It's not about why would someone sabotage a plant, you know, because we don't think a disgruntled employee is going to necessarily. They may attack their own company, but we didn't foresee that they're in a situation where they're trying to take out the whole grid. Not saying it's never going to happen. It just doesn't fit in well with what we think are the most likely scenarios that are going to cause big impact, because right now we haven't seen that big impact event. Yes.
And you know, we use the Pacific Gas and Electric example. You know, they think that was a cyber threat. They think it was someone that knew exactly what transformer needed to be hit and destroyed to cause a disruption locally. There's also a theory out there, the 7 bullet theory, and we talk about that in the upcoming slides, where with sufficient insider knowledge of how the system operates, if you knew where to go, 7 well-placed shots with a high-powered rifle could take out the system. So,
can't wait for that stuff.
Hey, we're talking about it now. Yeah. So attack vectors. This will align really well if you were in Chris Nickerson's presentation. You know, no talking beforehand, but it lines up really well with what he talked about, the physical, the electronic, and the social kind of convergence of attacks. So from a physical standpoint, substations, our substation environment, are mostly unmanned. I mean, how many of you have distribution subs right next to your house, right? I mean, they're just fenced in, about a 6-foot fence, pretty standard. Larger substations, transmission substations are largely the same. There's not a lot of communication going out there. Not everyone's deployed video monitoring. Certainly not a lot of security personnel residing at a substation. It's very easy to find a location on Google Maps, use Google Earth, or you can even go to Platts.com and order an entire diagram of the U.S. national grid and see all the major interconnection points, find the substations where they're located at, right? So you can do that and get in there and do some type of physical sabotage. Yes, ma'am? Platts, Platts. Yeah. It gives you diagrams and maps. Yeah. That's the disclosure part. Thanks for pointing that out. So you can go there and get that type of information. And when the regulations first came out for us, a lot of the pushback we got was, why do I need to do this cybersecurity stuff? I can just go take down a tower, right? And we would see that where I live in Oregon all the time. A lot of, as you can imagine, a lot of hippie-ish folk. But I love the state of Oregon and Washington and wouldn't move from there. But there was people that have a lot of political agendas, and they would literally go and remove bolts from transmission towers, and they just fall to their sides and disable transmission lines. Like, it happens, right? And we catch that. I mean, those are real physical attacks, and it's a very good point, but it doesn't mean you shouldn't care about cybersecurity. But certainly the physical vector is very easy. It lacks anonymity. It puts yourself at danger for being caught, unlike a cyber attack, or I shouldn't say unlike, but, you know, it's a little more difficult. Yeah. Great point. So in general, right, most of our generation is not nuclear. Nuclear generation plants in particular have extremely stringent physical controls. They have continuous physical monitoring program. That's something that's been called out with the shooting at the Navy Yard, right? They call out that contractors weren't being verified and continuously checked. Nuclear is totally different. They have a real physical security defense in depth perimeter. They do a lot of monitoring. They have specific security staff that are well trained, ex-FBI, ex-police officers that are manning and monitoring those stations. In our conventional plants, hydro, solar, wind, coal, natural gas, not necessarily the case. And security can vary based on geographic location. There's some plants that are out in the middle of nowhere. And when you walk up to the plant, it's a rent-a-cop security guard that asks you for your ID. They just take a look at it, and if you know the name of someone that works at the plant, they let you get in, right? And the thought is, and a lot of people kind of scoff at that when I mention that during outbriefs to executives, like, well, you can't just walk onto the plant. Well, you can. You give them your ID. I'm going to see the plant manager. I'm here from Ernst & Young. I'm here from Deloitte. Chris Nickerson said that yesterday. He's like, Deloitte gets to go everywhere. Ernst & Young can go everywhere, right? You're just expected, right? So, you say that, and then you're supposed to go to the visitor desk. But oftentimes, like, I can just drive up to the gate where everybody else walks in, and they're not necessarily checking badges. It's easy for me to get there. And once you're inside the plant grounds, the facility itself, because of what it does, it's pretty geographically spread. You can get from bag houses to coal houses to slurry halls. I mean, you can get to wherever you need to within walking distance. No one really questions you. Everybody's walking around.
Just make sure you got steel-toed boots.
Yeah, steel-toed boots, jeans, hard
hat.
hat. That's all you need. You can get in there. And it happens, and we've done it. I'm not just speaking hypothetically. Like, we've actually done and executed that type of maneuver, and lots of other people too in their social engineering experiments and work. Mentioned the large components difficult to replace. Talked about that. Mechanically, so this gets into more of the principle of electrical engineering. So one of the attack vectors, and this relates to the Aurora vulnerability, Stuxnet, things of that nature, and it's the idea that you can disable protective equipment. You can circumvent the controls that are meant to protect the system from destroying themselves or creating a problem on the grid. So mechanically, you can actually disable some of the safety equipment. You can physically go and get to it. So if you have a physical attack and you've been able to breach the perimeter, you can get to the generator. You can disable the turbine control system, the vibration monitor. You can do those types of things and cause overspeed trips and things of that nature. There's also the idea of remedial action schemes, and again, I don't know how many of you actually work in the power and utility sector, the electric sector, but remedial action schemes, under voltage load shedding schemes, under frequency load shedding schemes, these are all engineered safeguards that are meant to protect the system from destroying itself, making sure that our way of life is protected, that we don't drop an entire grid, we drop small portions of it, so we have a graceful degradation. You probably heard that term a lot during the conference today. Well, if you can circumvent, you can use those remedial action schemes, those UVLSs, those UFLSs against the grid. You can use it against itself. If you know where you need to create trips, when the loads are at their peaks, you can cause equipment damage, overloads, and circumvent the safety system. From a logical standpoint, we've got quite a few points here we want to go through. Industrial control systems in general, and I think we know this, lack authentication and encryption. And we're not talking about like in an energy management system or SCADA system where you have a nice, Windows OS-based system or a Linux-based system where you have people logging in and using that authentication. You can enable strong passwords. You can encrypt communication within a control center. We're talking about out in the field, like the equipment that actually is giving field telemetry and sending it in. There's not a lot of authentication or encryption there. And that relates to that last bullet with DNP3 vulnerabilities. The systems that we use are very susceptible to man-in-the-middle attacks, right? You can do DDoS attacks. There are a lot of attacks that the protocols and the way the system operates in sending data provide for an attack vector. I think we all know that vendors do not necessarily build security in their products. It's an overhead cost. So certainly you'd be able to exploit default passwords, default accounts, system accounts that not even the operators know exist, not even the installers know that exist, things that are there, you can exploit those. We know that our security standards are outdated. They're based on principles that don't even make sense anymore, like password entropy, right? That's how many characters you need in your password from a cybersecurity regulation standpoint for the electric sector. 6 characters. Right? It has almost no entropy to it with what we're capable of. Not deploying passphrases. That's not even capable on most of our systems. Right? And that's just one small example. And then who hasn't heard of Shodan? Everybody knows Shodan, right? That was in some talks yesterday. Over 1 million. There's SHINE, which is I always forget what the acronym stands for, but it's the specific identification of industrial control systems that exist within the Shodan database. And right now they're at over 1 million ICS devices that are connected to the internet. And some of the early exploits that we have seen were getting to development systems, ICS development systems that were open and connected to the internet that could lead you in and get you a path into the control system.
It's time for the fun stuff.
Yep, time for the fun stuff now. Enough background. Okay. All right. So when will it be attacked? We think supply chain is one of those issues that makes it the time is right. That was one of the points that was made earlier. When will the time be right? Well, a supply chain attack would be something that would take advantage of a time-based attack. If you are looking to disrupt operations, disrupt a market, you can attack the supply chain. A good example of this from a non-kind of cyber attack standpoint is the Fukushima reactor disaster. And that was caused by natural disaster. And when that occurred, when the Fukushima reactor went down, it severely affected electronics and the auto industry. We had prices increase and decrease. You can manipulate the market in that manner. So just something to be aware of. Also, the U.S. auto manufacturing, right? There was a loss in brake supplier, and that caused $9 million in loss over an 18-day. Excuse me, $900 million loss over 18 days. And that can be caused by a loss of power, right? A lot of these facilities, they do have backups, they do have support, but they're typically only going to operate for 7 to 10 days on their backup supplies. So if you can disrupt the electrical distribution to this supply chain sector, you can disable how we live our lives, right? How we can repair our equipment. Metal refineries, Alcoa, one of the largest aluminum manufacturers in the United States, they depend heavily on external power being provided because of the range of their equipment. They have to get smelting pots up to very, very high temperatures in order to create aluminum products. So a loss of power to them can result in hours of delay, loss of hours of production, sometimes days. Sometimes they can't even restart their equipment because it's so cumbersome. So it can create a really large disruption. And we think that fits into organized crime, and that could also be a terrorist act to the point that was made. If a terrorist wants to disrupt our way of life, that supply chain attack can certainly do that. So we think that this could be used by organizational crime units or even those terrorists to kind of short stocks, create the opportunity to make money, things of that nature.
So we wanted to make money. Is it clear now? This one's a little bit different only because it only takes one plant. If in fact you can only take out one plant, that's not grid-wide hack, but the important thing is if a lot of people understand this, then we could see a lot of generation plants get targeted.
And to the point of not hitting a single plant, it's the idea of a distributed and coordinated physical attack, and this is that 7 bullets theory. And this fits very well into terrorism, even just the insider threat mechanism. If you have enough knowledge, right, you can understand where you need to go and what components you need to destroy in order to cause a massive cascading outage. The eastern grid is very different from the western grid. The eastern grid is very interconnected. It relies on a lot of rolling power between organizations. A lot of different balancing authorities and transmission operators handle that. But if you know where to disable certain transformers, you can cause enough frequency and voltage fluctuation in order to disable the grid and cause cascading outages. Like I said, with that plat site where you can go and get a map of where all the substations are, right? And you can see what their ratings are, what they do from a megawatt perspective. That's how you can pick them. You can pick up a hunting rifle at your local sporting goods store, right? I mean, the background checks are pretty minimal, so you can even get it legally and go do what you need to do. We think this would be also really well aligned to a terrorist attack, and this is the one that we tried to specifically cite for terrorism. We think it could be much more devastating than 9/11. 9/11 was certainly horrific, right? But it had a smaller, narrow focus on the attack. Although it impacted all of us, the idea that you can actually take out an entire eastern grid, right? That would destroy everyone's life. You're talking hospitals, schools, manufacturing, supplies like water treatment, sewage. You're taking everything out because everything relies on electricity. Yeah. No, go ahead. Yeah, thank you. To repeat on the question, is it possible, and I'll just summarize and tell me if I get it wrong, but the question really is, can I utilize smaller generators where security is going to be weaker just due to company size to essentially manipulate and damage a larger component in the system or impact a larger utility? Does that sound right? Yeah. So to address that, yes, you can, and it kind of follows that Aurora vulnerability type aspect. If you have a generator, a series of generators that can impact or change frequency and voltage in a rapid manner, it would be possible to cause some outages on a larger generator that can't compensate or do it very quickly. But the windows of opportunity are very small. It is something that's very difficult to do, but it certainly is possible.
It's just harder. We're trying to make it easy for you guys. So, okay. So, and we need to speed up. We recognize we're a little bit over, but hopefully you're still here because it's a good presentation. So, how many people are familiar with ICCP? Handful of people. Okay, so for those who don't know, ICCP, this is the protocol that basically, the grid is basically a nation of islands. There's just a whole bunch of people that run it, and some are bigger than others. But at the end of the day, everyone needs to kind of let each other know what's going on within their system and what's going on with yours. And ICCP is that protocol. So that's how they at least chat to all their neighbors. So what's important to understand, this is the one thread that runs through the entire grid. And as we talked about, there's been a lot of focus on DNP3 as a particular protocol, and it's very problematic. So again, and it suffers from a lot of other things in terms of being unencrypted and not well authenticated. So we think it'd be very possible for someone to go ahead and put together a nice little worm. And guess what? It's going to be the one way that someone would really get across the whole grid. This is the grid-wide breach. For that purpose, though, we do think it is a little bit complicated, but this is a kind of situation where we'd expect this might be a little bit more on the Stuxnet level. It might take significant resources to put it all together, but we don't think this is that unfeasible whatsoever based on everything else that we have seen to date. And then we got one last one for you. So who's familiar with Oasis? Okay, a couple people are. So Oasis is a website run by a company called Odie, and this is where everyone trades. This is where most of the trading goes on between companies. It's a website where they can tag what's available and they can buy and sell, and everyone goes through that website. Nice idea, right? And they'll even tell you on their website, we've got a great data center in Minneapolis. Like, they're telling you exactly where to look for them in this oh-so-well-connected city, I assume, in the middle of the country. So, and they've got people already pushing the heck out of their system, 80 terabytes a day being changed between 700 companies. So, imagine if we were to buy ourselves a nice little DDoS. DDoSes aren't expensive, not hard. But it turned out a 16-year-old was the mastermind of Spam House attack. So this is one that also is really interesting. Now, no, we would not take out the grid, but the chaos that would occur from doing something like this would be insane because no one would know what they're buying and selling their energy at for a significant period of time. It takes a while to bring in just to do the contract, let alone implement some sort of DDoS mitigation solution. So for at least a week, pretty much no one on the grid would know what they're doing from a buying and selling perspective. We think activists would find that a whole lot of fun. So there's a good way for them to go at it.
So we tried to give just 4 examples of scenarios that we think would either result in making money or creating chaos and assigning them to a threat actor. And things that we think that we can do about it are going to be the following. We've come up with 4 ideas that we just want to present here.
Vendors. They're the root of all evil, essentially. And we know that just kind of everywhere. We'd love to see...
and we're not vendors, we're advisory consultants.
Yes, we don't sell any products. So, yeah, not us. We would love to see something like the regulators step up and do something like PCI did with requiring people to only use secured products. Carrots, right now, we're seeing a lot of talk behind the new executive order for critical infrastructure. It's voluntary right now, but I think it can be made really strong with a lot of incentives. So, if you're going to encourage people, to give really low government loans, if you're going to go out and purchase highly, well-secured products, because normally people are expected to put something out there and last 20, 30 years. So we've got to find a way for them to actually replace all these legacy systems.
And we think a couple of things can help in the regulatory model. So, and I've just got another minute here, and we'll let you go. Appreciate the stand over a bit. We know that self-regulation typically doesn't work. You're biased, right? You don't want to force yourself to do something that you don't have to. So changing from a self-regulated model will be really important. I think that helps and supports the vendor idea and the carrot idea. Not a voluntary framework, but if you want to do business in our sector, if you want to supply us ICS equipment, then you need to meet these minimum specifications, and whether it's like an EAL type of item with an insurance level or whatever it may be, but putting that into the regulatory model, making it unbiased, making it external and objective, and making vendors applicable to it. Distributed infrastructure, you hear a lot about this from the microgrid standpoint, and this is a lot of smart grid technology. Talks about smaller generators being able to affect large generators. Well, if you can distribute your infrastructure, make it more widespread, generate smaller amounts of power in smaller local areas, you can segregate your network essentially, just like you would for network security. You can segregate your generation, you can spread it out, you can have a graceful degradation when something occurs. You can absorb these smaller and smaller losses instead of having these huge generation plants that are producing all of your power, these huge substations that are being responsible for transmitting most of it out to customers.
And that's it. We're a little over.
Yeah, thanks.
I apologize. We'll stick around afterwards.